Okay, sorry for the late post on this one, but let's go ahead and talk about graphing. Now, you've seen graphing before, so let's kind of review what graphing is and how we're going to use it in chemistry class, okay? So I have a couple of rules that I want you to keep in mind when you do graphing in chemistry or any sort of science class moving forward. Okay, so the first thing, I'm not going to read everything in here, but I at least want to talk to you about what I would expect if you were doing a graph, okay? So the first thing is you're always going to graph your title in the following form. You're always going to say the dependence of whatever your dependent variable is on the independent variable, okay? So let's look at an example here. Okay, so we're studying the effect of temperature on the speed of a reaction, okay, so like a chemical reaction. All right, so we're changing the temperature to known values, so our temperature is going to be our independent variable. So why is it an independent variable? It's because we are changing it. We know what our next temperature is going to be, okay? So we are changing temp in the experiment. Okay, so if I keep reading, it says, because I don't know the speed of the reaction at the temperature that I set, the reaction rate, or how fast the reaction is moving forward, is based off of the temperature that I give, right? So the temperature stands alone, where the rate depends on the temperature. So therefore, reaction rate is dependent. Why? Because it changes with temperature. Okay, so if I was to give a title to this graph, I would say the dependence of reaction rate on temperature, okay? So reaction rate is dependent on temperature, so that would be the title of the graph. Second thing, this is review, okay? The x-axis is always your independent variable, where the y-axis is always your dependent variable, okay? And we'll talk a little bit more about this when we get into an example. You always need to label x and y-axis and give them a unit, okay? And then we're always making a line graph, okay? We aren't making bar graphs in here. We're not doing anything with statistics, okay? So everything that we do in this class will be a line graph, okay? And then next thing, never, ever connect the dots on the graph. I'll show you what you do with the graph, okay? But we're not connecting the lines. And let's talk about why for a second. Okay, so if I'm doing a graph in chemistry, I'm going to have different dots on my graph. The reason why I don't want to connect them is because that line that I connect the dots with doesn't mean anything to me. Okay, I can do this thing called a line best fit, which literally takes half of the dots on the top of the line and half of the dots on the bottom of the line. And what this line does is it averages all of those dots, okay? So anywhere on this line, I can go up from the x-axis and figure out what the y value is, or go from the y value and figure out what the x value is, okay? And we'll talk more about this when we get to an example, okay? And then we're going to make sure that the data is graphed as large as possible in the space that you're given on the graph, okay? So meaning I don't want all of your values really this close when the graph is this big, okay? Space them out as much as possible. Okay, so those are the steps that I want you to follow. So let's look at some examples of good and bad graphs. Okay, first one, this is a bad graph. So let's point some things out here. Lines are connected, bad. No title, bad. Axes aren't labeled, bad. Okay, so all of those things aren't good with this graph. Okay, so let's look at an example of a good graph. Okay, good graph. Okay, this is the line best fit that I was talking about, right? See how half of the dots are on the top and half of the dots are on the bottom, right? So meaning if I was to say, oh, I'm going 100 miles per hour, I can go up to the line and go over and say my cost of my ticket would be around $200. Does that make sense? Even though I don't have a dot there. Okay, that's what a line best fit means. So this says the dependence of traffic ticket. So I know that traffic ticket is my dependent on cost of automobile speed, which is going to be my independent. Okay, and if I look here, my automobile speed is independent, which means it's on the x-axis, where the cost of the average speeding ticket is dependent, and that's why it's on the y-axis. Okay? So doesn't that look nice and beautiful? This is how all of your chemistry graphs should look when you do a graph for this class. Okay? So that's graphing. Let's look at how we would calculate slope from a graph. Okay? Slope from a graph is just rise over run, right? So rise over run, and we're counting when we're doing rise over run. Or I can say change in y value. This delta here means change in. So I can say change in y divided by the change in x, or if I wanted to convert that into a mathematical equation, it would be y2 minus y1 divided by x2 minus x1. Okay, so all of these guys are equal to each other. Doesn't matter which one you use as long as you can figure out slope. Okay, and if you remember, slope is going to be m, or the m variable. Okay, so let's look at some examples here to try and figure out what our slope is. Okay, now you'll notice that there's no lines here or spots here on the y-axis, so I'm going to fill those guys in. Okay, so let's find the slope of A. Now, it's always important when you're trying to find the slope that you find two spots on the line that go through an origin. It's a lot easier to figure out what that point is if it's on an origin than if it's in the middle of an origin. So what do I mean by that? If I look at A here, this guy looks like it's going through this little line right here. So I'm going to take that to figure out slope. And I'm going to take this guy right here because it's going through an origin to figure out slope. Okay? So now there's a couple of ways I can do this. I can do rise over run. So I'll do that one first. Okay? So if I'm going from this spot, so from here over here, okay? And so my rise is up, right? Like a high riser, rising up. So I'm going to go up. Make sure I'm counting by whatever my axis is. So I'm counting up by 1, 2. So my rise is 2, okay? And my run is 1, 2, 3, 4. So my slope for this line would be 2 over 4, which we can reduce down to 1/2, which is always also 0.5. Okay, so that's one way of calculating slope. Let's look at another way of calculating slope. Let's do m is equal to y2 minus y1 is divided by x2 minus x1. Okay, so for B, this guy's on an origin, and I really don't have another origin, so I'm going to do this one because it's kind of in the middle, which might be easy to find. Okay, so my first, it doesn't matter which one's 1, which one's 2, but I do need to know what the origin is. So for B, this is my x is 1, my y is 1. Okay, and then for this point up here, my x is like 2.5, where my y is 6. Okay, now it doesn't matter which one you denote as 2 and 1, as long as you keep the order the same. Okay, so I'm just going to call this guy 1, this guy 2. Okay, so my y2 is 6, so I'm doing 6 minus my y1, which is 1, and I'm going to divide that by, okay, now I need to make sure that these two are lining up with what I have here, which 6 lines up with 2.5, so I'm doing 2.5 minus 1, so then I have 5 over 1.5, and if I plug that into my calculator, my slope shall be 3.3. Okay? Good so far? All right, let's do the last one. Okay, now what's different about C here? This is going to be a negative value. Why? Because it's not going straight up from the origins. It's coming backwards like this. So I know that this is going to have a negative slope. Okay, so let's see here. Let's do m is equal to y2 minus y1 divided by x2 minus x1. Okay, so what I'm going to do here is y2, first of all I have to pick two origins, so I'm going to do this guy, and I'm going to do this guy. Okay, so this is 5, 1, and this guy right here is 1, 7. 1, 7. Okay, so I'm going to do 1 minus 7 divided by 5 minus 1, which is negative 6 divided by 4, which 6 divided by 4 is 1.5, so this is a negative 1.5. This negative means I have a backward slope or a negative slope, okay? So let's answer a couple of questions based off of this graph, okay? First that thing says, which line has a negative slope? Hopefully you said C. Which line has the smallest positive slope? That's going to be line A. Notice how it's much smallest, yes. Notice how it's not as steep as B, and that's why it has a smaller slope. So A has the smallest positive slope, where B is very steep, like a hill, and that means that it has the greatest positive slope. Okay, so that's how you do, or the rules for a graph and how to calculate slope. Next video is going to be on how you actually make a graph.